Hello and welcome back to question 9b, complex numbers. Now in this question, they're really testing you on how comfortable you are switching between the different forms of a complex number. So how many forms of a complex numbers are there? There are 3, right? So you have the Cartesian, the polar, and the exponential form. So the Cartesian one is a plus bi, polar form is r into cosine theta plus I sine theta, and the exponential form is r times e to the I theta. In this question, you're given e to the I theta, which means that the modulus of this complex number z is equals to 1. Okay, and the argument of z is equals to theta. What does that mean? What does the modulus and the argument mean? It means that, right, if I were to plot out the position of this complex number on the Argand diagram, on the Argand plane, right, the distance of this point to the origin is 1. And we can usually represent this with a unit circle. Yes, so if I plot it out, right, this point has exactly a distance of 1 from the origin. Next, what does the argument mean? It means that the angle that this line that I just drawn that it makes with the positive real axis is going to be theta. That's what the argument and the modulus of a complex number means. Now, what are we supposed to do in this question? We're supposed to show that if we do a geometric series with this complex number, 1 plus z squared, all the way to z to the n minus 1, show that this is equal to this monstrous looking fraction over here. Now, a few things to take note. Number 1, what we're supposed to show, you realize that there is some sign terms over here. That kind of hints that we need to change to polar form. We need to change to polar form, okay? And then this one over here looks a bit suspicious as well, but maybe we'll get there in due time. So first of all, I'm going to quote the partial sum of a geometric series. Okay, 1 plus z plus all the way to zn minus 1 is going to be this formula. Okay, the next thing I'm going to do is I'm going to change this into our exponential form. So some of you might wonder, why is this? Okay, so let's do the obvious one first. Z is equals to e to the I theta. That is given by the question. But why is z to the n equals to e to the I n theta? Let me very quickly explain, since this is a revision. Okay, so if z is equals to e to the I theta, okay, so let me just remove this. Oops, I wanted to remove, not to make it even messier. So this is z, which is equals to e to the I theta. Okay, I know that there's no r, right? Usually exponential form have a r e to the I theta, but r is equals to 1. Okay, so what is z squared? When we multiply complex numbers together, okay, and this is the magic of the exponential form, it is as simple as multiplying the magnitudes, the 2 r's of the complex numbers together, and then adding up the 2 angles. That's it, right? So if I take z times z, first, the magnitude is 1, 1 times 1, the magnitude of my z squared is going to be 1, meaning my z squared is still going to be on the unit circle. Number 2, I add the 2 angles together, which is 2 theta. So by an estimate, I guess this is 2 theta. This is my z squared. Z squared is equal to e to the I 2 theta. So you can imagine this. Z cubed will be e to the I 3 theta. Z to the power n will be e to the I n theta. Right, this is the magic of the exponential form. Okay, so that's what we're going to do. Okay, z to the n is e to the I n theta. And the next step over here, from this step to this step, will be a bit puzzling, right? But let me explain what I'm doing. Okay, so what we're going to do is, from the numerator, factor out half the argument, e to the I n theta over 2. Okay, and from the denominator, we factor out again also half, e to the I theta over 2. Now, why are we doing this? Is because if I actually have this one out here, if I take the numerator, divide by the denominator, I will get e to the I n minus 1 times theta over 2. E to the I n minus 1 theta over 2 is exactly this term over here. Correct? E to the I n minus 1 times of half theta. Okay? That is exactly this thing over here. So I kind of like gotten part of what I'm supposed to show. Now for this part over here, you'll be thinking, oh, doesn't this make it worse? Like, this is looking a bit more complicated than what it should be. If you take a closer look, This is an exponential form with argument n theta over 2. This is the exponential form of sort of like this one, but with a negative argument. Now that should kind of ring a bell, right? We have the argument and the negative argument. In fact, I can show you on the diagram over here. Say z has an argument theta, and I take half the argument, I square root z, right? I'll get something still on the unit circle, but half the angle, and then I have negative of that. Can you see that these two are actually conjugates? Meaning that these two are conjugates, this and this are conjugates. Yes? So this is really nice. So if that is a conjugate and I want to use polar form, then I kind of know that if this is z, then it will have some cosine theta over 2 and sine theta over 2. Right? And the one at the bottom will be cosine of negative theta over 2. Sine negative theta over 2. But as you know, cosine of negative theta over 2 is just the same as cosine of theta over 2. In fact, you can actually check on the diagram itself. The x coordinate would be the same for the conjugate, but the y coordinate is negative of each other. Yeah? So let me change this also to negative sine theta over 2. Familiar? Our negative angle identity from secondary 3, trigonometry. Right, you might have forgotten, but it's okay. Right? If we take the negative 1 minus the positive 1, I'm going to get cosine theta over 2 minus cosine theta over 2, that's 0. And then I'm going to have negative sine theta over 2 minus sine theta over 2. So that's a minus 2 sine theta over 2. Okay? So what happens is this one will give me a negative 2i sine n theta over 2. The bottom one will give me a negative 2i sine theta over 2. We can cancel off the negative 2i, and that will give me the sine n theta over 2 and sine theta over 2 that we saw in the question. Not to forget to convert this one into z to the n minus 1 over 2. And we have managed to show what the question wants us to show. Right? I hope this has been helpful. If you need clarifications, do drop a message below, and I'll see you in question 10.